Right. Good to be here. I guess we have only English speakers here. Hands up. Okay, so it's English then. All right, very excited to be here to talk about open source data science, which is something that we have looked into for a while, and we have come a bit, and it's nice to share it with all you guys. So let's start. That one. Shortly, the mandatory slides about Svenska Spel, Sweden's largest betting and casino company, state-owned, and it's a merge between two companies in '97, and we're sort of covering basically the whole range of betting industry except for online casinos. We have offline casinos. We're 1,600 employees roughly, and we contribute quite a sort of hefty money bag to the Swedish state. And some of our brands are, I guess at least most of you living in Sweden have probably bought a Triss a lot at least. But we have lotteries and we have sports betting and all kinds of products. So, just setting the stage of what we're working with is we're quite a data-intensive company. Very fast-paced business. Purchase cycles are very short, and it generates a lot of data. I mean, for example, live betting is a very fast-moving, intensive part of the business. It's also a business and a marketplace that is really disrupted digitally. I mean, Svenska Spel is sort of coming from a monopoly situation, but in terms of that nowadays, it's not really there. So it's a lot of entrance into the market digitally, and it of course disrupts things and creates new areas of competition. And for us, that means that our means of competing in this business is very much focusing on customer experience and analytics, because that is sort of a given when we're dealing in a digital context. In terms of our infrastructure, we're very much oriented towards open source, partly because of a lot of those products are the only ones that can really handle the type of workloads and so on. So we have a lot of NoSQL stores and so on. It's also a way of implementing agility, because we have public tenders when we go pay for stuff. So it takes a lot of time, and it sort of hinders our agility a lot. So open source is nice because we can be very fast. We're using most of the open source technologies. We have big Cassandra clusters, we have MongoDB clusters, we have Elasticsearch. We also use traditional technologies like Oracle and so on, MySQL, MariaDB. And we're running Hadoop since 2013, so we're sort of 3 years into it now. And we have a lot to learn, but we know some things at least. Some things that work, some things that don't. This is what our pipeline looks like. It's not really relevant, and I will not go into details in explaining this, but I would say 75 to 85% of our data is streaming, so it's basically in real time or a second latency. So when someone purchases a product or places a bet, we have it inside the platform in a very short time frame. So we stream it through Kafka, and then we have some jobs that are storing the data into HBase, and we're also indexing some parts of the data so it's easy to search for. And we store that in Solar and Elasticsearch, depending on the workload. And then after that, where I will focus most today is the batch layer. Yes? Because we want low latency. We have a product where we need to be able to search for a particular transaction trace in real time. And if we store it in Hive and search for it in Hive, we introduce a lot of latency before we got the results. So that's why. I understand your question, because it's not really useful for all kinds of data. And we actually bypass it also for some streaming parts. But then we store it we batch it into Hive nightly, and then we build our data warehouses structures and data pipelines on top of that. So, in terms of the business side, we're coming from a traditional organization. We had a market research team, and we had a sort of BI team on IT developing front ends. So when I started in 2014, that was about the time when we moved the business front of the IT side onto the business side and formed an analytics team. We have also a sort of virtual integration with the analytics team running SAS mainly, which is CRM, customer analytics. And right now we're looking at data science as everyone else. So we want to, or we see the need to be a bit more explorative in our data, being a bit more agile. Modeling data to, from a data lake into data warehouse, it takes some time. Maybe Warescape can make it quicker, but we don't use it yet. So for all the data that we haven't really put in our data warehouse, it's probably some of it are very valuable, some of it are crap or noise. So data science is one way of sort of exploring the data. So as you see, we have a lot of products, but we had a lot of question marks on the data science. I mean, what kind of tools do we want to introduce? So looking at our design targets, it's a good starting point. Really, I mean, there are a lot of data science processes or analytical processes, but most of the time we need to sort of course, understand the question mark, the business question at hand, but then sort of getting all the data, preparing the data, modeling, evaluating, and deploying. So for us, that meant that we needed to be able to access streaming data, because a lot of it is streaming. We need to be able to reach data with sort of real-time or low latency, and that is where HBase and Elasticsearch and those kind of NoSQL products come into place. And of course, batch data stored in Hive, stored in Oracle, stored in HDFS, and so on. And then one important thing, of course, is to be able to work with all kinds of data, regardless of what it is. It can be flat and relational. It can be log files. It can be deeply nested JSON files, which are the most common ones in our organization. So we need to be able to explore it and visualize it to see where we might find value. And then, of course, we need to be able to deploy data wrangling to get it from, as Eric was into, I mean, apply the functions on data required to take it from an input state to an output state. And a lot of the times we're dealing with not super large data sets, but still too large to handle in memory. So we need to process it distributedly, but then also we want to take it maybe off the distributed side to the in-memory site to be able to work with it. So really having the choice of what framework to apply the particular problem to. And then, of course, stats, all kinds of stats and machine learning. And then, yeah, writing it to any destination state. And then, of course, the big one, preferably one tool that should be agile and it should scale. So this is sort of what we set out looking for. Our candidates, I mean, outside the big data world was quite simple. It's R or Python, basically. If you go open source, which was our goal in this perspective. Can talk about this a session if you want to. I personally prefer Python, but that's me. R does everything as well. Looking at the big data side, it was trickier because we haven't really seen the consolidation, and there's sort of so many candidates that can be used for different types of workloads. You have the sort of the SQL engines like Hive and Drill. You have the scripting languages like Pig. The frameworks, Cascading and Scalding, are quite nice. And then the new ones, Flink and Spark, and then a lot of sort of machine learning and streaming frameworks. So really what made me happy was this news. Introducing data frames in Spark. That was sort of the kickoff, because then we had the final glue that could connect Spark to Python. And this has evolved incredibly fast since this news was a year ago. Yeah, more or less a year ago. So what we could do with this new data frame, data frames in Spark, is that we can have a Python-based environment running both Spark and local in-memory Python. So we can actually choose. I mean, if we have less than 5 million rows, maybe we take it into Python. If we have more than 5 million rows or billions of rows, we keep it on the cluster and work with Spark. And the other thing to tie it all together was Jupyter Notebooks. How many of you have heard or worked with Jupyter? Okay, so we have great potential here. One of my favorite tools for working with analytics and data workloads. I personally worked with it since we called IPython Notebook, and it was quite early. I will actually try to show this live soon. But it's a fantastic tool. Single user, though. So what we wanted to do is actually to have an environment that we can scale out to new users seamlessly. And there is a project called Jupyter Hub, which is multi-user environment. So you log in, and in our case, when you log in, we spawn a Docker container, which is your local environment. And then we have a persistent sort of file storage for all your analytical notebooks as well. But it works really well. We've had some trouble with sort of memory allocation and stuff like that, but I will not go into any sort of technical details because I will fail that one. So really what it looks like, very simple. You log into an address internally. You ask for username and password. You type it in, and you enter your own personal area. We have your folders and projects and your files. And it's, I mean, for you who haven't used a notebook, it's really hard to explain why it's revolutionary. You have to try it, I think. I'm not able to explain it, but really it's quite simple. It's where you can combine your comments and descriptions and explanations of what you do with code and with visualizations and results of the code. So you can really sort of put a full analytical process inside the same notebook, and then you can export it and you can present it with a sort of PowerPoint slide functionality. And it's really powerful. And as you see, graphics are integrated. You can put in whatever, YouTube clips, images, and so on. And it integrates with basically most code languages. You can run R, you can run Haskell, you can run whatever basically inside it. And it integrates with Bash and everything. Try it. They have a try.jupyter.org. You get the Docker container exactly as we have, and you can run code. Fantastic tool. So, live demo, hopefully. I had to speak to our DevOps a couple of hours ago, so I hope the environment is up. So let's see here. Okay. Right, so far it works. So basically, this is just a short demonstration to show you how it looks. I will not go into details, but I will touch on the different parts of the environment. So we have a lot of, imports of a few libraries that I want to use, some Spark features, a Seaborn visualization, and so on. The first thing is, for example, integrating with command line tools, which is quite useful. Both to look at the local files, but we can also talk to, in this case, our HDFS command line to look for files in the cluster. So I can list available files in our data lake. So we have some clickstream events in Avro. If I want to connect to them, it's quite easy to load it into a data frame. So I basically just declare the page views, and then I read it into Avro format and load it, all the files inside this partition. So I will save you the time of waiting. I've sort of prepared this in advance. So you can have a count easily. When you have this, basically you get a lot of functionality like auto-completion. So I can select my page views. And then I have a lot of functions to look for, correlations, covariance, crosstabs, count distinct values, and so on. So it's quite nice. And anytime in this process, I can implement steps before or after the processing step I am. So it's very debuggable. It's very easy to print out intermediate results within your process, which is great for iterative work. So in this case, I can look at top 5 rows of the data. So I have some header column and so on. And as you see here in the schema, this is the schema I actually get from our Avro files. So it's sort of coded into it in advance. Most of the cases, we have just JSON files. And in that case, Spark can help me to parse out the schema. So it actually samples the data, derives the schema, and gives it to me. And then I can work with it the way I want to. But here is quite simple. It's just the header row that is nested. So for example, if I want to look at the page views, I can make it simple. Use page views, group by, header.destination page, and I count. And it gives me this kind of setups if I sort this. If I want to do something, because here we have it just counts the full URL tree. So if I want to look at the sort of top domain, I can do that quite easily with implementing a new column called top domain, and I just split it by with the dash and take the second element in that case. Otherwise, I will get just zeros. So when I print this, I get the top domain. So this I can actually do immediately because it's lazy evaluation. So it doesn't really compute anything unless I use an output operation of some kind. A very nice feature as well with Spark is that anytime I have declared a variable, I can register it as a temp table with just one simple line of code. So I have my data, register temp table, and call it page views. And then I can run SQL on it, regardless of where I am. Which is also quite nice, especially for sort of exploring the data. The data frame API is very good for pipelines, but I mean, if I want to just write a lot of SQL queries on it, it's quite powerful to be able to do it like this. So this example, select top domain, count star from page views, group by top domain. And then the function that really does it all for me, basically, it's the 2 pandas. It's one line, and I take the data set, the result where I have there, from Spark into my Spark, the driver program on the Docker container, and I can work with it in memory. So sort of, I mean, big data wrangling is really about having billions of rows, consolidating it down to a few rows that are interesting, and then working with those. So you really want to avoid big data as much as you can. So this is what I can do here. And then I can look at, for example, information on it. I can run page count head. And you see now it's quite rapid when you put it in a data frame, pandas data frame in memory. If I want to look at the top 10, I can just make a page count sorted by count, taking the first 10 rows and displaying those. Inside here, I can also get to the help files for all the functions, so I can see exactly what it expects, the columns, the axis, ascending, true or not, in place, and so on. And it sort of applies for all functions, which is quite nice. If I want to distribute this, I can do the same, plot it. And we can see the top domains generating traffic for this particular data set. So it's sports betting, it seems, and then your jackpot, sort of descending order. Another way to just show some other data is looking at session lengths. So in this case, I just took a sample of the data. So I take the time of a page view and the session ID, sampled it, took it into pandas, and it's quite easy to just work with this. Then looking at the data, so, and then I can convert it into datetime objects. And then quite simple, group it by session, take the minimum of the time and the maximum of the time per session. Then it's quite easy to calculate, I mean, the max time minus the minimum time. Extract number of seconds, divide it by 60 to get minutes. And then I say I want sessions that are more than 0, because I used the sample, so it's a lot of sort of unclosed sessions, probably. And then I can distribute this in a histogram, for example. I didn't do it. Like this. So it's a really trivial example, but it still shows the power of the workflow, getting from a log file in the back room of our cluster into a visualization with sort of repeatable and documented steps. I didn't go into any sort of machine learning, but inside both Spark and Python, we have basically all the algorithms that we want to use available, and all stats libraries and so on. Any questions so far on this one? Right. So that was basically what I had, and experiences on this. I could do it like this instead. Is that the gains was that really fast to deploy. We had this basically from the idea into production in less than a week. Actually done pretty much as a skunk work, but it really works, because we just had I mean, Jupyter Hub on Docker. Basically, you can just download it from Docker and you can adapt it a bit, have it in place. And getting Spark to run on Yarn is quite simple. So we just needed to update some Python versions and so on to make it all work together. It's great for exploratory analysis and prototyping. We have done some more sort of production-ready flows, looking at deeply nested JSON data, sort of flattening it together and extracting insights as the end result. It's very nice because it bridges the gaps between systems. And I mean, regardless of sort of data lake strategies, you will never have all data in the same place. It will be all over the place. And wherever it is, you should be able to reach it and analyze it together with other types of data. Open source, it's free of charge, which is also nice. I don't know if SAS or the other guys are here, but it's really nice. We get an environment that really enables us to do whatever we would like. It doesn't cost anything. Rapid development. It's really, really fast. In terms of pains, we haven't really exposed that many pains. We will probably run into scalability concerns when we get more people on the cluster. But that is also sort of a happy problem, because that's what we want to do. We don't want to have our cluster underutilized. So we'll see where that goes. We will have a sort of cultural and skill problem. I mean, working with this kind of way is quite different from sort of requirement top-down approaches. It's also code-based. We have a lot of analysts running SQL and SAS. So it will be a small step to go into this environment, but we'll see how it goes. And for us, the next steps is deployment and version control. We need to integrate it with Git and our automatic deployment pipelines. We're sort of seeing exactly how we're going to define that. We will have other types of jobs that needs to be scheduled. So right now we're running USI for our data warehouse jobs, and it's sort of the source of all our problems. So really we need to get rid of that quickly. We're looking at Airflow is the top candidate right now. We're looking at also Luigi from Spotify, for example. But overall, it's a really nice nice way of working with your data science. So shameless commercial. If you want to work with this, we're hiring. So questions? Yeah, go ahead. I expect you to. Yes, Anders.
So thinking about the next steps, and I mean, it's also nice to have as an interactive and open environment to do data science analysis, but also have you considered going to next step of productionized data pipelines using technology?
We're currently using HQL because it was sort of part of least resistance when doing our production jobs. But we're looking into Spark. We have actually a prototype also for basically what the Warescape does. It's a data warehouse automation tool built in Spark that is metadata driven. So we will get there probably. We don't have a time frame. But I guess so. By the way, Anders is going to speak more about this, about how it's done at Spotify tomorrow at the Stockholm Hadoop user group. So that's also, yeah, no worries. Other questions? Yes. Yes. Basically, what we have is underneath the. I can show you actually. So inside the environment, we have here. It's called kernels in the notebook. So here you see we have a number of different kernels. We have different Spark versions, and we have Python 2 and 3, and we also have some Scala kernels. So basically, when I select one of these kernels, it spins up the appropriate stuff. So basically, when I pick PySpark, it sets up a Yarn client version of Spark, and it sort of just eats our configuration files, puts it onto Yarn on the production cluster or the test cluster, depending on the environment. And you get a Spark driver with workers on the cluster. And we have a dynamic allocation, so if there are a lot of people using this at the same time, you will get sort of a shared portion of the cluster resources. Anything else? Yes?
That took you 2 weeks to set up?
1 week.
1 week, all that.
Yeah.
Kernels and everything.
Yes. And we had, of course, cheated on it. We had run, I set up myself just to try it out, a local Spark Yarn client on my local laptop notebook. So we had a sort of, we know where we wanted to look for potential problems and the sort of design. But setting it up was really quickly. The biggest problem was getting to, it required Python 3. We didn't have that on the cluster. So that was a problem. Otherwise, it would have gone faster. So it's really lightweight. Really, it's nothing big. I mean, it's really when you spin it up, it just ships a YAR to the cluster, onto Yarn registers, and then you're good to go. Yes. We actually not we haven't put anything into production from this environment, but in terms of normal production jobs, we have a metadata trace. So we have basically a hierarchical model of system, workload, and instance. So we basically tag all the data with that, and then we have a monitoring in a lot of different tools to see if it has run. So we put a lot of metrics into Graphite, and then we visualize it and so on. But the next steps in terms of pipeline is, of course, metadata management, data lineage. We need to look at sort of starting to document our data lake. It's starting to be pretty big. And it's not good if it's sort of in the head of the analysts what data we have and what it means, because our IT engineers they don't like documentation. Anything else? I guess time is up as well. Yeah, exactly. I mean, if you're interested more, connect with me on LinkedIn and visit Spotify tomorrow evening. And try it out. It's a great tool. And you don't have to use it to Spark and big data. Just a notebook with Python, it's more than you will need. Okay, thank you.